Well, a ruler has markings on it, so you can actually see the markings. Okay? Yeah. All right. So the first thing that we're going to talk about, we're in section 4.7. This is the title is medians, altitudes, and perpendicular bisectors. We're first going to talk about medians. All right. So I'd like you to draw a triangle, any triangle on your page. All right, and then label the vertices A, B, C. So we're going to talk about the median. The way that you find the median, all right, there's 3 steps that we're going to follow. The first thing that we're going to do is we're going to use a ruler to find the midpoint of the side. So use a ruler to find the midpoint of one side. All right, so I'm going to choose side AB. All right, I don't have a ruler right now on me for this program, but if I was going to measure, I would assume it'd be somewhere right around there. So I'd find the midpoint of a segment AB. Okay. Then step 2, I would mark my segments congruent. Mark the segments congruent. So that means that A to my midpoint, I'll call this M, is congruent to MB. That's what it means to be midpoint. All right. Then I would go to the opposite vertex. So which one is the opposite vertex to side AB? It would be vertex C, right? I'll draw that one. So from vertex C, so I would take my straight edge on my ruler, and I would go from vertex C all the way to point M. Okay, that is one median. That's a median right there. Okay, that's one median.
So what is step 3?
Yeah, sorry. So draw one side. Yep, you got it. One side. So draw a line from the opposite vertex to your midpoint. Okay. So we're going to do the same thing for the other 2 sides. Okay. I'm going to go AC. I'm going to use a ruler. And if I was going to use a ruler, I would mark my midpoint there. And then I'd make my segments, my 2 congruent segments. And then I would go from the opposite side, the vertex, over to my midpoint. That is my second median.
So it depends on how many sides you have.
It's a triangle, so I'm going to have 3 sides. Yeah. These are, we're talking about triangles here. So 3 sides for sure.
To find the midpoint between AC, do we just do the middle of AC?
Yeah, you measure it with the ruler. Yeah, you measure with the ruler.
What about CB?
Yep, we're going to do that next one. So if I was going to measure with a ruler, I'd probably end up close to right about there. I don't have a ruler right now, but you guys have rulers, so you're measuring however long your line segment is. Then I go from the opposite vertex down to my midpoint here. Okay? And if you do this correctly, they should all meet at a single location. Okay? If you measure correctly, he's like, dang it, they didn't work out, right?
Didn't we not mark our segments?
They all meet at a single location, at a single point. So that's a good clue that you're doing it correctly. So each one of these is called a median.
Is this what this worksheet is basically about?
Our next topic is the altitude. Now when you think of altitude, you probably think of how high something is in the air, right? The altitude, like the altitude of an airplane, or the altitude of a building, or the altitude of a bird flying, right? How high something is in the air. So here's what I want you to consider right now. I'm going to give you the main idea of what altitude is, and then we're going to look at some special cases with 2 other triangles. So taking a look at my first triangle there, you see how I have the base of that first triangle highlighted in yellow?
Yeah.
And then I have a dot that's above the line. It happens to be a vertex, but just imagine that the 2 other sides of that triangle aren't there. So all you see is the green dot and the yellow highlighted ground. So pretend that the yellow highlighted part is the ground, and the green dot is like a dot in the air. Okay? So the question I have for you is, how would you measure the altitude of that? If that dot was like a plane flying, where would you measure from? The ground. And would you measure like straight up from the ground, corner of the ground? Perpendicular to the ground. Okay? There you go. you would measure perpendicular to the ground.
Now what do you have?
Because, after all, the shortest distance from that green dot to that yellow line is the line that's perpendicular to the ground. That's the shortest distance, right? That's how we measure altitude. So, what we would do is the altitude would be the line that goes straight down perpendicular to a side. That is going to be the altitude. Alright, that one right there. Now, just like before, there are 3 altitudes for a triangle. So if I was going to highlight this side, and that was my ground, and this was my vertex over here, I would measure again perpendicular to that side. So I would have to go perpendicular to the side, so straight up like this, right? So it would have to be perpendicular to the side.
You do this for every side.
And we're going to do it for the other side as well. Absolutely.
Oh, so you go from every vertex?
Yeah, so then if I take a look at this side over here, and I go perpendicular to that side, right there, and what do you notice about the altitudes? They also do what?
Intersect.
They also meet at a sec. So the altitude is the shortest distance.
Oh, it's where they all intersect. That's the altitude.
No. The altitude is the actual line segments from the vertex to the opposite side perpendicular to that side. Shortest distance from a vertex to perpendicular opposite side. It's not very elegant, but you get it. And notice that what? They all meet where? They all meet at one point. So they meet at one point. So the thing with the altitude is that it's going to be perpendicular to a side because we're measuring, considering the height of how high something is off the ground.
So,
Perpendicular to a side.
shortest distance
From a vertex, perpendicular to the opposite side.
And there's 3 for every triangle.
Yep,
Alright.
just like medians, there's 3 for every triangle. Alright, now here's something interesting happens when we take a look at, what type of triangle is this over here?
right triangle.
That's a right triangle. This is a right triangle. And then what kind of triangle is down here? Scalene obtuse, right? Okay, so let's take a look at this. So let's look at the right triangle first, alright? I'm going to highlight the ground. If that's my ground, what's the opposite vertex? The right angle. So this one here, right? And then I would draw perpendicular to a side, right? And that would be like that. And that would be called my altitude, right? Okay, now, let's highlight this side. Let's consider this part the ground. What's the opposite vertex? This one over here, right? So where is the altitude?
At the vertex.
It's the actual leg itself. See that? On a right triangle, 2 of the altitudes will actually be the legs of the triangle itself because it's already perpendicular, right? So check this one out. If I highlight this one, if I'm looking at this ground, where's the opposite vertex? It's over here, right? And where's the altitude? Well, it's already given to me. It's that side there.
Wait, that's going to the left. I thought you were supposed to go.
So there's only one.
No, there's still 3. It just so happens that, the legs, 2 of the legs,
Altitude is
happen to be the altitudes themselves. Something also funky happens when we're dealing with an obtuse triangle. Okay?
goes outside the triangle.
It goes outside the triangle. Exactly. Okay? So, here's the question, right? Let's say that this one is the ground. I'm going to have to extend that ground a little bit. Right?
Weird.
Totally weird. That's okay. Because which is the opposite vertex to that side? That would be this one up here, right? You guys agree? That's the opposite vertex to the side? I want shortest distance. The shortest distance has to be straight down. And that's okay that we had to extend the side. So that's my altitude. That's okay because it's still perpendicular to the side. You get it? Alright, now let's do this. Let's make this one the ground. And I need to extend that one a little bit, right? Which one is the opposite side?
Wait, the yellow
Sorry.
is the ground?
Yeah, now the yellow is the ground. Which one's the opposite vertex? That'd be this one, right? Is that what you guys meant?
Yeah.
Okay. So if I go straight down, perpendicular to the ground, I would get this one. You guys agree?
Wait, so they don't always meet. Oh, wait, no.
They don't always meet inside the triangle, but they do always meet.
at one point.
Yep.
Okay.
Okay, what's the only one I haven't done yet? This one. Let's call this one the ground. Okay?
Oh, and it's just
Okay. Where's the opposite vertex?
straight down.
The bottom one?
This one, right? So if I go straight to that one
Straight down.
and I extend it,
They meet.
look, and that's perpendicular side. Look, they still all meet at a point. This one happens to be outside the triangle. That's okay. All right, we're going to talk about perpendicular bisector of a triangle. First, let's start off with a segment, okay? Here is a line segment. So what is a perpendicular bisector? Well, it is a segment that's perpendicular to this segment, and it cuts the two pieces in half, right? So I would measure and find the midpoint. So the midpoint would be, I'm guessing, right about here, okay? And then, at that point, I would then take a ruler or a straight edge, and I would draw a perpendicular bisector at that point, meaning that that's a right angle and that this segment is congruent to that segment
Aren't all lines
in the middle. So the first thing we did was we would use a ruler, and we found the midpoint. So we would find the midpoint of our segment. Second thing that we did was we would mark our segments congruent. Mark the segments congruent, which we did. So we'd say that segment is congruent to that segment. And then the third thing we would do is we would draw the perpendicular bisector. So perpendicular means it's at a right angle. Bisector means it cuts the segment exactly in half to two congruent segments. That's what that means. The same thing works for a triangle. Okay, so the same idea works for a triangle because a triangle has three sides, so we just do this 3 times. So the first thing I'm going to do is I'm going to take segment AC. I would find the midpoint using a ruler. I'd mark the segments congruent, and then I would draw in the perpendicular bisector. So it would be something like this, if I could actually draw that perpendicular. Does that look about right? There you go. Perpendicular bisector right there. Okay? Do the same thing for AB. I'd find the midpoint. I'm saying it's probably about there, using a ruler to see. I don't have a ruler right now, but if I did, that's what I would do. And then I would mark my segments congruent there and there. And then I would draw in the perpendicular bisector. Oh man, I was way off on this one. There you go. Is that better? It's close.
Wait, do you draw the line all the way through the triangle? Or
Doesn't have to be. Yeah, it doesn't matter. It's just a line segment. And then same thing again. For this one, find BC. I'm guessing it's right about there. Mark my segments congruent. 1, 2, 3. 1, 2, 3. And then draw the perpendicular bisector. And if you do it right, which I was close, they should all meet in one point again. So that's a perpendicular bisector.
They have to meet inside the line.
Okay, give yourself a line segment. And oh no, go away. Okay. So let's call this R, and let's call this S. And what do we call the points at the end of a line segment? End points. Very good. So that'd be an end point. End point. End point. Okay, let's find the perpendicular bisector. This is the center of mine, and then I'm going to draw in a perpendicular bisector, and I'm going to give it some length, like that, about like that. Hard to do. Boom. Pretty clear, no? Pretty good. So that's the best I can do right now for that. Okay, and call that perpendicular. Okay. So I've drawn in the perpendicular bisector. Now, put a point on that perpendicular bisector, and I'll use green. So any point that you want. So I'll put a point there and I'll call that point A. So let's put one above the perpendicular bisector, and let's put one sort of below the perpendicular bisector, which I'll call this point B down here.
It doesn't matter where.
Doesn't matter where, as long as it's on the perpendicular bisector. Okay? It turns out that from the endpoint to my point A is going to be equidistant from the other endpoint to my point A. So those two are going to have to be, this and this would be, they would be the same distance. So any point, okay, I'll write this down for you. Any point on the perpendicular bisector will be equal distance from the endpoints. The saying, right? It's saying that this point, point B, is the same distance away from S as it is from R. This point, point A, because it's on the perpendicular bisector, is the same distance away from R as it is from S. That's all it's saying. Okay, so points on a perpendicular bisector are guaranteed to be equal distance away from the endpoints of the segment. Okay, so angle bisector. What does the word angle bisector mean? So it means that it cuts my angle exactly in half, right? So do you see that I have this angle here is now congruent to this angle here? Because that's the definition of an angle bisector. You guys see that? The yellow and the blue angle are congruent. Yes. Angle bisector, right? The orange ray is the angle bisector to angle RAS. Is that cool? Everybody cool with that part? Alright, so that means that my yellow angle and my blue angle are the same. Okay, now, pick any point that you want on the angle bisector, the orange ray. Put a point anywhere that you can. Okay, and I'm going to put a point, I'm going to say right here. Okay? So what's the shortest distance to ray AR? Is it a perpendicular line? Is it a skew line? What is it? Perpendicular line. So if I draw a perpendicular line back to AR, so I'm going to do my best to draw a perpendicular line back to AR. Okay? What's the shortest distance to ray AS?
Same.
Perpendicular line back. Okay? What's your best guess as to what you think those two are? Those two green lines I just drew. Those would be congruent. Yeah, those would be congruent. Okay? Pick a different point. I'm going to go inside here. I'm going to pick this point here. Shortest distance back to AR is the perpendicular line, right? Perpendicular line segment. I have that one there. Go the perpendicular line segment to the one. They are congruent. There you go. There you go. So here's what we're trying to say this. We're trying to say that any point on the perpendicular bisector is equal distance away from the sides of the angle.